Yesterday class, we discussed about the multi-node, how to create, what are the prerequisites for the multi-node. I hope all you understand. And we also discussed about the how the blocks will be split into different blocks, how the blocks will be spread into different machines, and also how the replication will be there, how the horizontal scalability will be there. So yesterday we discussed about all these things. I hope all you understand about this one. Tomorrow we will do we'll make a one practical session also. I think in your machine also we will try to install that multi-node also. Tomorrow will be. Today we will go through. Yesterday we created 3-node cluster, but in production how the Hadoop cluster will be there. I will share few details. In real production machines or Hadoop cluster, basically we will have the, maybe it will be in any cloud. It will be there, or they will be install their own cluster kind of thing. They will install, otherwise they will use the in cloud computing. In cloud they will maintain some cluster, or they will prepare the some own clusters. So basically we will have the network switches, and network switches we will have the different racks. So like this only in real time, in real time how they maintain the cluster, and how they maintain the large number of machines, nodes, means they will have the different data centers. In data centers they will arrange the machine in a racks order. Next slide, I will show how the real time racks will be there. I will show you. So like this, in real time racks will be there. So while we are making the cluster, they will maintain all the racks information in name node. So how we are maintaining the blocks information, files information, machines, same way they will maintain the rack. Same way they will maintain the rack information. So in real time, we can install the name node in one machine. Job tracker will be installed in the one more other machine. Secondary name node in other machine. Like that, we can install the different services in the different machines. Also in production we can install. So generally, if you take one rack, first machine we install the name node. All the other machines we install the data node task track. Like all the other machines we install the slave machine. Another rack we install the job tracker, and the slave machines we install the data node and task tracker. This way, we can maintain the multiple racks, and each machine we can install the different slave machines, or we can install the different services in this one. So like this it will be there. If we want, we can install all the name node, job tracker, and second node in one single machine. But for suppose if we have the more machines, maybe lot of burden is there for the name node. So that's why only generally in production, if you have the large nodes, then mostly they will install all the services separately, name node separately, job tracker separately, secondary name node separately. Like that, they will install all the services differently. So this is how the racks will be there. How it will be there. Suppose here previously we discussed about the only if one data node fail means automatically data it will be there in another machine, and automatically we will fetch the without data loss we can access the data. But same way in rack awareness, in racks, how the data will be there. Suppose if you have the multiple racks, in real time how it will be there, they will have the information about the racks. Suppose if you have the one file related, some blocks will be in rack 1, some blocks will be in rack 2, like that it will be there. Suppose if one rack fails, means automatically the data it will be in the other rack. So replication will be happen in the different rack. Suppose if I store the one file, so one copy of the blocks will be in one rack, another copy of the blocks will be in another machine. So like that it will be in different racks. So two copies won't be stored in the single rack. Like that it will be distributed to the different racks. That will be taken care of by the internal framework, will take care about the that distributing the blocks to the different racks, and also maintain the replication in the different tracks. It will be take care by the this HDFS framework. It will take care, and all the racks information and these information it will be in the name node. Suppose one rack is failed, means we don't lose the data. So other copy of data it will be in the racks. Like that the data it will be there. So here if you observe here, so same way how the meta information, data nodes information or block information will be there. Same way rack information will be there. Rack 1, what are the data nodes is there. So each data node, what are the blocks will be there. That information name node will maintain. So that is about. So in real time racks will be like this. Data center we will be arrange the racks like this. So each one is the one rack. Like this the racks will be there. So suppose one data node is failed because of hardware, or the full entirely data nodes, maybe there is a chance to fail the full rack also because of network problems or network issues, and also there is a chance of failing the one single node in the rack. So if one data node is failed or the full rack is failed, you won't lose the data. So other data it will be, other racks also data it will be there. So like this the racks will be there in the real time in production. These are the I think example of the Yahoo cluster. This image is the Yahoo cluster images. So in production like this, the racks and the data nodes and everything will be arranged like this. For this rack maintenance and the same time this cluster maintenance and everything, separate network team will be there. For maintaining the Hadoop cluster, separate Hadoop admins will be there. So they will take care about the balancing or backup and other things. They will take care. Hadoop admins will take care. Okay. This is a brief idea about the how the racks will be there. How the once the rack will fail, how the data will be, how we can access data without loss. These are the details about the rack. Next, while writing the files, what are the operations will happen in the backend. So basically now if you want to write one file to the I think yesterday we saw we are writing file to HDFS. So it is splitting as a blocks and it is distributing to multiple machines. So basically what are the operations will happen backend means. So first if client try to run the command copy from local, so first it will go to the name node. Based on the file size, name node will give the different block. It will estimate how many blocks will be there, and it will give the block IDs. So this client will interact with the data nodes. it will write the data to the different as a different blocks, and once the data is written to the data nodes will send the this blocks status to the name node. So every time data nodes will send the odd bits to the name node. So after certain some few odd bits, so it will send the block status to the name node. Based on this block status information, name node will keep the meta information. Like this, it will happen backend. So name node won't store any data, so it will just give the based on the size of the data, it will be give the block IDs. So then the data will be returned to the uh, uh, data nodes. So corresponding block IDs. So data nodes will return the status to the name node. Like this, the backend will be happen. So same way for writing the files to the HDFS. First, what are the things we need to suppose if I want the if I want to read one file, so first we need to connect to name node. Name node will give the corresponding block IDs. So block IDs, and it will give the which node the blocks will be there. So corresponding data nodes will connect, and we will fetch the data. Like that, read operation will be there. Ask first one is connect to name node. Then ask name node to give the list of data nodes that is hosting the replicas of the block of the file. Then client then directly read the data from the data nodes without contacting again to the name node. First time only we need to contact the name node for the block IDs. Once we got the block IDs and data nodes information, directly will go to the data node, and we can fetch the data from the data nodes. Like the read operations will be there in the backend. So like this, the write and read operation will happen backend. How it will interact with the name node and data nodes. Okay, this is about the different services in the backend of the HDFS, name node, data node, secondary name node. How we can write the data to the HDFS. How we can what are the operations will perform backend while reading and while writing. So this is all about till now, if you want to copy the data from local to HDFS, or if you want to perform any operations, till now we interact with the HDFS commands. So instead of interacting with the HDFS commands, we can perform all these. We can copy local file to the HDFS by using HDFS API. We have the Java API. So initially, if we want to practice how we can copy the data, we can go through the HDFS commands. Later, if we want to automate anything in the projects, then we need to go for the HDFS API. So if we want to find whether the file exists or there in the HDFS, or if you want what are the files are there in the HDFS, or if you want to count the number of files in the particular directory, or if you want to copy from local to HDFS through Java code, we can do it by using we have the one HDFS API. By using that one, we can do all these operations. So in projects, if you want to automate anything, if you want to do anything through code, we need to go for the HDFS API instead of writing the HDFS commands is a manual process. Just if you want to check anything manually, or if you want to copy data manually, then we will go through the HDFS commands. Otherwise, if you want to do any automation kind of thing, if you want to do anything through coding, then we need to go for the HDFS API. So for accessing the file system, we need the three things. First, we need to get the configuration object. In configuration object only, we will have the different configuration things. Configuration relation settings will be there in the configuration object, and in the same way, path object. If you want to connect to, if you want to access any file or folder, we need to get the path object. Then we need to get the file system. If you want to perform any operations on the file system, then we need to get the file system instance. Okay, previously we saw Hadoop we can do in three modes: local file system, or we can do with pseudo distribution mode or single node cluster. Or one more thing is cluster mode or the distributed mode. Local file system means simply instead of there is a no concept of HDFS. Simply we'll connect it to the either it will be Windows path, or if we are working in Linux machine, simply we'll connect it to the local file system. Pseudo distribution mode, it will be whatever the operation will perform in the pseudo distribution, same thing, same commands, or if you write the same programs, or if you write any programs, or if you write any commands in the pseudo distribution, same thing without changes we can run in the cluster mode also. But pseudo distribution we will run everything in the single node, but in cluster mode or distribution mode we will run the commands or the programs in the multi-node and multiple machines. So file and the HDFS is represented using the Hadoop's path. So path will be we need to specify the what is the name node and the port. Then we need to specify the user, in our case user training or some other file you can specify. If you want to get the public system API, we need to use this one, public system get configuration. Those I have exception. This is the syntax. We will see next slides. We will see the code. So these are the steps we need to do. First, we need to get the config. We need to create the configuration object. All these classes it will be available in the HDFS Hadoop jars. So I will provide those details also while explaining the code. I will provide what are the jars we need to download, from where we need to get those jars. I will explain. So in that Hadoop jars, we will have these classes. Configuration class will be there. We need to create the configuration object. Using the configuration object, we will connect it to the Hadoop cluster. By using this configuration only, we will connect it to the Hadoop cluster. We need to tell the configuration object where is your name node and the job tracker is running. We need to tell these information. Where is our data node and the job tracker is running. Next, we need to connect it to the default name. So this property will tell us about the address of the name node, where the name node is there. So suppose if you are writing the code in your local machine, if you want to connect to remote machine, then we need to specify the this one. We need to specify the master and we need to specify the port. Then we need to create the file system object for if you want to perform any operations like the copy from local, or if you want to get the files information, or if you want to get the whether the file exists or not. All these by getting the by using file system object, we can perform all these operations. If you want to practice API, here Amazon book will have the more details. If you want to practice this HDFS API in VM, we are having the Eclipse. So it will be desktop. Will have the Eclipse. We can open and you can practice where the programs will be there. How we need to load into Eclipse. All the details will be there here. I will show next. So here all the details will be there, how we need to run the application and how we need to get that HDFS project to the Eclipse. All the details will be there, how we can do in the this VMware node, how we can do, all the information will be there, and same way how we'll get the configuration and everything will be there here. How we can create the make DAS will be there. So if we want to create the directory, we need to first we need to create the file system, then we need to access run the methods on the file system, make DAS. If you want to creating the file, or if you want to write any data to the particular file, we can get the file data input stream and file data output stream. FS data input stream and FS data output stream will be there. By using this one, we can read and we can write data to the particular file. So this is counting files or directory. This is if you want to check whether it is a directory or if it is a file, we can check using the file system object. We can check it. Okay, that is all about the theoretical thing. So we will see how we can get the jars and how we can run it. We will see. I think in desktop we will have the Eclipse. So no need to install the Eclipse. So directly you can access the Eclipse and you can write the programs. So while starting, we will start the Hadoop cluster also. We will start. So before interacting with the HDFS API or any other tools, first you need to start the Hadoop cluster. We need to check whether we are running the all the services are running or not properly. We need to check before accessing through API or before accessing any tools, Hive or other tools also. We need to check whether the all the services are running or not. We need to check. So from Eclipse, I think you can practice the next MapReduce or HDFS API also you can practice. So no need to install. So simply if you double click on desktop Eclipse folder, you will get the Eclipse. Then we already having the HDFS related project. So just we need to export. Sorry, we need to import the project. So already then we need to go for the existing project into workspace. Then we need to browse. So here in HD workspace, home training HD workspace, we'll have the project called using HDFS API. So we will import that one. So before going to that one, so we need to import the different Hadoop files, Hadoop core and the related files. We need to load Hadoop core other files is we need to load to the this project. If you want to write the Hadoop related classes, this configuration and the file system, if we want to access these classes, we need to import the some packages, arg.apache.hadoop.conf.configuration. So we need to import all these packages. These packages, it will be there in the this one Hadoop jar file. It will be there. So from where we need to get all the jar files. I think if you already installed in the Hadoop, so automatically we will have the all the jar files in the lib folder. So from there only we loaded all the jar files. User local Hadoop lib. So from this path only we point all the jar files to this project. Build path, configure build path. So add external jars. So user local Hadoop lib, we loaded the all the jar files to our project. These are the some dependent jars, and these are the basic what are the jars we needed for the Hadoop core. Other jars also will be there. Hadoop core is the main jar, and one more jar is the, I think this one, Hadoop thrift or Hadoop capacity scheduler. These are the other jars, and remaining all the other jars are the related to dependency jars. So once we load it, we can access the all the classes in the Hadoop API. We can access. So before going to all these things, just I will comment all the other things. So first steps, what we need to do means we need to create the object for the configuration. Then we need to set the what are the, if you want to set any parameters, we can set here conf.set, and here we set the for which data node we need to connect. I explained here. So instead of localhost, we will change to master. Now we are running master. So instead of localhost, we will change to master. So here is the path directory. Just we are getting the home directory. In our case, home directory is user training. So if we run this program, we'll get the home directory. Then we are also we are going to create the one folder under the home directory. This folder name is HDFS input directory. So here in these steps, what we are doing means, so we are checking whether the directories already exist. So then we are trying to run the fs delete. So we'll have this file system will have the different methods like the append, copy from local, and the delete, make directories, or we can also have the create. So this file system object will have the different methods like make dir also will be there, make dir. So like this will have the different methods. So we can access the based on our usage, you can use the different methods. So this is for the deleting the particular file in the particular directory in the HDFS. Same way, if we want to create any directories, we need to use the fs.make direct make dir. So we will run this one. Before going to run, we will check the Hadoop. I think that is the default path. Once we trying to create the directory, then it will we'll get the this path. So if you check here, my HDFS home directory is the user training. So and also we try to we are able to create the directory, one more directory under the user training path. So the directory is the this one, user training HDFS is created now. So if you go to here HDFS, we can see that one, user training. This is the default directory, user training. Under user training, we created the one directory, HDFS input directory. So instead of writing the Hadoop space fs space make dir and the directory name, we can create by using the API also we can create. So through API also we can create. Suppose now if we run the code again, so we will these two lines also will execute. Why means now we already this directory exists, HDFS input directory. So then first it will check whether the directory exists or not. Then if the directory is there, then it will delete that directory. So now if you check here, so the directory is already present on the HDFS, deleting it. So like this, if you want to delete any directory, you can remove also. If you want to create the directory, you can create also. Then we can go for the this part, creating the file and writing on it. We will go through that one. So under this HDFS input directory, I'm going to create one file, sample file. For that one, I'm using path object. This input file I'm checking whether it is exist or not. If